Alright, welcome to our Unit 10 review, all inverses. In this video, we're going to look at every single type of inverse that we've discussed throughout this semester and what they all look like. It'll be a pretty long video, and you can feel free to skip to the examples or the problems that you are struggling with on the review. So example 1 says find f inverse of x for f of x equals 3, and y'all need to know, what do we call this symbol? This symbol right here means, hey, we want to find the inverse of a square root. And you have to know that the inverse of a square root is, in fact, a square. Okay, so with that being said, what do? Well, the first thing you do is you always change f of x into y. We know that. So y is equal to 3 square roots of x minus 7 plus 6. From here, we know that we want to switch our x and our y. So where I see y, I put x. And where I see x, I put y, and then we write everything as is. Now at this point, what we have to do is we have to get this square root by itself, and we just do some basic algebra. Step number 1, we get rid of our addition through subtraction. Okay, at this point, we now have x minus 6 is equal to 3 square roots of y minus 7. Okay. Next thing we do is we divide both sides by 3, divide by 3, and we now get this. We have x minus 6 over 3 is equal to the square root of y minus 7. Now then, this brings us to our big question. What in the world is the opposite of a square root? Well, we said it's a square, which means we put this in parentheses squared, and what we do to the right, we do to the left. At this point, on the left-hand side, we now have x minus 6 over 3 squared, and our square root and our square cancel, and this leaves us on the right-hand side, y minus 7. Now we're one step away from finishing this, so I'm going to pause the video and clean this up, and what I would ask you to do is I would ask you to finish taking your notes up to this point. Okay, so from here we know that we want to get rid of the minus 7 by adding 7, and notice that 7 cannot go into the problem. So what we really have, I'll do this in the same colors, is we have this x minus 6 over 3 squared, and then that minus 7 has to just remain separate. That plus 7 remains separate to the right. And the final thing you want to do is you want to take that y value and switch it back to f inverse of x is equal to, I'm going to write the rest of this, x minus 6 over 3 squared plus 7. And there you go. There is your inverse. Alright, pause the video, finish taking your notes. Let's move on to our second example. Okay, in example 2, what do we see? Well, we see f of x is equal to 3 parentheses x plus 2 squared. And I'm just going to take this note over here and say, hey, look, we have a square. What is the inverse operation of a square? Well, it is in fact a square root. So this is the exact opposite of the problem that we worked with before. Okay, so we kind of flying through this, we change f of x into y. Y is equal to 3 parentheses x plus 2 squared minus 8. From here, what we want to do is we want to get the square by itself, so we can add 8 to both sides, getting rid of our subtraction. Okay, we have y plus 8 is equal to 3 parentheses x plus 2 squared. At this point, we can go ahead and divide both sides by 3. That goes away. And we have y plus 8 over 3 is equal to our function by itself, x plus 2 squared. So remember, how in the world do you get rid of a square? What is the opposite of a square? And it is a square root. And so we just take the square root of both sides. Now at this point, our square and our square root cancel, and what we get is this. We get, okay, we now have the square root of y plus 8 over 3 is equal to x plus 2. Okay? And at this step, we can just simply, oh, I'm so sorry. Look what I did. I never switched my x's or my y's. How about this? I'm going to fix these real quick. You have my utmost apologies. F of x switched to y. And so in our very next line, this y right here and this x should have been switched. Okay. In fact, to highlight this change, let's go ahead and put this as an x. Let's put this as a y. Okay. Once again, this y right here should have been an x. This x should have been a y. And if you caught that up till now on your own, good for you. Alright, sorry I didn't hear you sooner. Alright, so really this should be an x over here and a y right there. And one more time, this y and this x should be flip-flopped. Let's see here. So we should have an x on the left and a y on the right. And at this point, you will simply subtract 2 from both sides. This 2 cannot combine in there. And so what we really have is this. We have the square root of x plus 8 over 3 minus 2 is equal to y. And by the way, I noticed that I had this mistake because our ultimate goal is to get a y by itself. And I knew that I was on track to get an x by itself. And like, okay, that should snap in like, hey, I made a mistake by not switching my x and my y. Alright, well I'm going to pause this video, clean it up just a little bit, and show you our final answer. Okay, so we see we have our y by itself, so what I'll do is I'll rewrite it as f inverse of x to the power of negative 1 is equal to the square root of x plus 8 over 3 minus 2. And you can see, hey, side by side there is the function and its inverse. Alright, let's move on to example 3. Okay, for example 3, we have f of x is equal to the cube root of x plus 4 minus 2. And what you have to know is that here, much like a square root, for a cube root, what in the world is the difference? Well, or the inverse. So for a cube root, our inverse is actually going to be a cube. We could even put the little 3 up top so you know what we're talking about. Okay, so let's not make a mistake here. We switch f of x into y, and we say y is equal to the cube root of x plus 4 minus 2. At this point, let's not make the same mistake as last time. We can take our x and our y and switch them. And at this point, now having performed the inverse operation correctly, we can finish this fairly simply. Notice there's no multiplication here, so that makes our life a little bit easier. We can add 2 to both sides by getting rid of that subtraction. We have x plus 2 is equal to the cube root of y plus 4. And remember, the inverse of a cube root is a cube, so we're going to put this all in parentheses to the power of 3. What we do to the right, we do to the left. Those cancel, and we now see this. X plus 2 cubed is equal to y plus 4. Now from here, getting y by itself is super simple. We can simply subtract 4, and I'm going to do a little bit of a shortcut. Since y is by itself, I'll write it as f inverse of x equals, and over here, we know equal the cube of x plus 2, or x plus 2 cubed, minus 4. Alright, let's move on to a fourth example. I would encourage you to pause the video and finish taking your notes. Okay, here we have f of x is equal to 1/2 x minus 4 to the power of 3, or aka cubed. And we have to know that the inverse of a cube is in fact a cube root. Alright, now let's see what this looks like in practice. We know we want to change our f of x into y. We can say y is equal to 1 over 2 x minus 4 plus 6. At this point, we want to start getting that cube. That didn't write. We want to get that cube by itself. So we can subtract 6, and wait a second. Guys, look at this. Look at me make these silly mistakes. Think about this. We're trying to find the inverse. We are trying to find f inverse of x for every single one of these problems. What do I first need to do to my x and my y? Well, I need to switch them. At this point, once you've switched them, okay, now we can go ahead and solve for y. Alright, so from here, we know we're going to subtract 6 from both sides. Subtract 6. We have x minus 6 is equal to 1 over 2 parentheses y minus 4 cubed. And notice I put this problem in here because it's been a while since we've seen how to get rid of a fraction in front. So remember, we don't ever divide by a fraction, we multiply by its reciprocal, and the reciprocal of 2 over 1 is really just 2. And in going to our next line, what we can do is actually distribute that to say, hey, this is 2x minus 12 is equal to y minus 4 cubed. Well, this brings us to the crux of our problem. How in the world do you get rid of a cube? You take the cube root. All right? At this point, the cube root and the cube, they cancel, and we have this. We have the cube root of 2x minus 12, which is equal to y minus 4. And to finish this out, we can simply add 4 to both sides, and I'll just kind of write our final answer. F inverse of x is equal to the cube root of 2x minus 12 plus 4 on the outside. I would encourage you, pause the video, finish taking your notes. Let's move on to our 5th example. Okay, take a look here at example 5. What we see is that our operation is a logarithm to the base of 4. And so the question then becomes, well, what is the opposite of a log base 4? And it is going to be 4. Here, let's call it log base 4 to the x. Well, the opposite of that is an exponent. So remember, the opposite of a logarithm is writing the x value as an exponent. Okay, so let's kind of see how this works in practice. First things first, we want to know, we switch f of x into y. Let's say y is equal to 3 log base 4 of x plus 2 minus 3. At this point, we know that we want to switch our x and our y because we're trying to find the f inverse of x. And so we can say, okay, well, x and y flip, and our problem is x equals 3 log base 4 of y plus 2 minus 3. Now, as always, we are simply solving for y. So we do our initial operations. We can add 3 to both sides, getting rid of our subtraction first. And we have x plus 3 is equal to 3 log base 4 of y plus 2. All right, from here, we know we can divide both sides by 3. And we have x plus 3 over 3 is equal to log base 4 of y plus 2. And this is where we get to this idea of putting things into the exponent. So you always look at the number that is your base. Here we have a base of 4. And so we're going to put everything into the exponent of a gigantic 4. And the way that I want you to say this is we say, hey, we're going to base 4 both sides. And what happens? Well, these two things cancel. Now I'm going to pause the video and clean this up a little bit. I would encourage you to pause the video and finish taking notes. Okay, so we now have this. On the left-hand side, we have 4 to the power of x plus 3 over 3 is equal to, and once those cancel, y plus 2. And from here, of course, we can subtract 2 from both sides, and we get our final answer, which I'll write just as soon as I kind of clean this up. We'll say this. Y has become f inverse of x equal to 4 to the power of x plus 3 over 3, and then that minus 2 has to be the same size as the 4. And there is your inverse function. All right, y'all. Finish taking your notes. Let's move on to example 6, which will be the final example of this video. Okay, here in example 6, we have f of x is equal to 3 times 5 to the power of x plus 7. Notice that this x plus 7 is in the exponent, so I can call this a to the x. And what we know is that this, an exponent, is the opposite or the inverse function of a logarithm that would look ultimately like this, x log of a. Okay, well, let's tackle it. So the first thing, of course, that we want to do is we want to change our f of x into y. And say, okay, y is equal to 3 to the 5 to the x plus 7 minus 8. And at this point, remember, when you are finding the inverse function, you take your y and your x and you flip-flop them. So we have x is equal to y. So x is equal to 3 parentheses 5 to the power of y plus 7 minus 8. we do our initial steps, we can say, okay, well, let's add 8 to both sides. Add 8, and we have x plus 8 is equal to 3 parentheses 5 to the y plus 7. From here, we know to get rid of our multiplication, we divide both sides by 3. And when that cancels, we have x plus 8 over 3 is equal to, and I'm going to leave a space here, 5 to the y plus 7. Now notice, what is the opposite of an exponent? It's a logarithm. And when I take the log of the right side, I can take the log of the left side. And what happens here is that it allows me to take this, anything in the exponent, and bring it down in front. So this is where the math kind of gets a little bit weird looking. So let's go ahead and write it up in the top right. We have the log of x plus 8 over 3 is equal to that y plus 7 comes down in front, and then we have the log of 5. In fact, y'all, I don't like squeezing in like that, so pause your video, finish taking notes, and let me go ahead and show you what this looks like way more cleaned up. Okay, so we have the log of x plus 8 over 3 is equal to y plus 7 log 5, and how in the world do you get rid of multiplication? Well, you get rid of it through division. So we actually divide both sides by the log of 5, and remember, when you take a logarithm divided by a logarithm, you can perform a change of base where this number in the denominator is now the base of your logarithm. So we have the log base 5 of x plus 8 over 3 is equal to y plus 7. And at this point, of course, we can subtract 7 from both sides and get our final answer. F inverse of x is equal to the log base 5 of x plus 8 over 3. And this minus 7 stays on the outside. And there, in fact, is our inverse. Alright, y'all, I know this was a longer video. Hopefully that you looked through the examples that you needed in order to work through the problems. I hope this helps you prepare for your test, and I'll catch y'all in our second video.